This video is going to walk us through the product of powers investigation, or the product of powers rule. So really what that means is by the end of this lesson, we need to know what to do when we are multiplying two bases. So I see that I have the same base and it is being multiplied together. So we're going to look at expanded form to kind of help us make sense of this. So for example, I know that 2 cubed, or 2 to the third power, is 2 times 2 times 2. So I'm going to write 2 to the third power like that. And then I have multiplied, so I've already done 2 cubed. Now I'm going to do 2 to the power of 2. So that's 2 times 2. And so when I count up how many factors of 2 I have here, I have 1, 2, 3, 4, 5 factors of 2. So I'm going to just put 2 to the 5th power right here. I'm going to skip the rule form column. Whoops a daisy. I'm going to skip that column for just a few minutes, and I'm going to fill this in when I'm done filling in the rest of the chart. But I am going to go ahead and fill in standard form. So standard form is when I would type 2 to the 5th into my calculator. So to do that, I'm going to do 2 times 2 times 2 times 2 times 2, and I'm going to get 32, and I'm going to put it right there. So I want you to pause this video, and I want you to fill in the chart. You can skip the rule form for right now, and we'll talk about what we've observed in the pattern in just a minute. So now that you have the chart filled out, what we want to do is we want to figure out what the shortcut is to get us from this first column here in the blue to exponential form here without having to write this column here with expanded form. So even though expanded form is really useful and it can help us identify patterns and it can help us remember the rule if we forget it, we really want to know a shortcut to get us from here over to here. So hopefully you have observed that all you have to do is add the exponents together. So for example, I had 2 to the third times 2 to the second power. And if I add the exponents 3 plus 2, that indeed gives me 5. When I add the exponents 4 and 2 on the next one, it gives me an exponent of 6. So, and we can see that if we look at the rule form, every single time I look in this chart, I'm going to be able to add the exponents to get to the answer. So like this one would be 5 to the 1 plus 3, which gives us 5 to the 4th. The next one would be 5 to the 2 plus 3, which gives us 4 to the 5th, and so on. So it's going to work each time that when I am multiplying the same base, I can add the exponents together, and then that's the shortcut. So that's what I want you to write down when it asks what the pattern is that when you multiply the same base, you add the exponents. So you can pause the video and you can jot that down in your notes, but what you want to do is when you are multiplying the same base, you want to add the exponents together. So now what I want to look at on this next section is, does it matter if the bases are really the same? So I want you to evaluate each one of these questions down here, and then when you are finished, you can unpause the video and check your work. So to evaluate this first one, you should have typed into your calculator 3 times 3 times 3 times 4 times 4. And when you do that, you get 432. And then this one, if we kind of think about, well, how might somebody go from this question right here to this one right here and think that they're the same? It looks like this person they multiplied the bases together. 3 times 4 is 12. And then they added the exponents together, because that's what we said we do, right? When we're multiplying the bases, we add the exponents. But when we write 12 to the 5th power out in expanded form and then type it into our calculators, we're going to realize that these are not equivalent. This is going to be 248,832. So the point of this question here is to point out that these are not equivalent, right? So you can't just take two bases that are not the same, so like right here, these two bases are not the same, you can't multiply those together and then add the exponents. So the big idea here is that the bases must be the same in order to add the exponents. But that's the rule. That all you have to do is if you are multiplying the same base, you add the exponents together. So for this one down here in section 3, I have the same base of 5. And so the rule tells me that if I have the same base, I can add the exponents together. So that would be 5 to the power of 6. So I want you to pause the video and I want you to work through the rest of the questions in that section and then check your answers in just a minute. So hopefully you've had a chance to work through all of those problems, and you should see that we are adding, or we're multiplying the same base each time, so we just have to add the exponents. Be real careful on letter C. If you have a base that doesn't have an exponent written here, there's a 1 that lives right there. And we can remember that because like we'd have 1 factor of 4 and then times that by 5 more factors of 4 for a total of 5 factors of 4. Go ahead and flip your paper over to the other side. And let's look at these here. So these are pretty much the same thing that we talked about, but we have some negative exponents, but we've already talked about what to do with those negative exponents. So let's see if we can put these together. I have the same base being multiplied together, so I'm going to add the exponents together. So I have 4 to the 8 plus a negative 5. Well, that's going to be 4 to the 3rd. So go ahead and pause the video and check your answers in just a minute. Okay, so in all of the questions in this section, we ended up with a positive exponent when we were finished. So we didn't have to do anything with those negative exponents in that section. So A, 4 to the 3rd, B, 2 to the 3rd, C, 6 to the 3rd, D, 5 to the 3rd, E is 3 to the 3rd, and D is 7 to the 4th. That is not going to be the case that we're going to end up with a positive exponent in this next section. So what's going to happen here is, let's see, I've got 4 to the negative 3 plus 2. That's going to be 4 to the negative 1. And then we talked about yesterday how you need, if you have a negative exponent, that you have to put that over 1. So if you end up with a negative exponent, you need to make sure that you move its location. You need to vote it off the island. So like on this one here, 7 to the negative 5 plus 2, that is 7 to the negative 3rd, which is going to be 1 over 7 to the 3rd power. You're going to find the same thing in section 5 when you're adding two negatives together. So like this one would be 8 to the negative 3 plus a negative 2. That's going to give me 8 to the negative 5, which will be 1 over 8 to the 5th. So section 4 and section 5 are very similar here. And then when you get down to the very last one, you just have to think about what these question marks would be in order to have that be a true statement. So for example, if I know that I have to add the exponents together, when I'm multiplying the same base, I have to think to myself, well, 7 plus question mark would be 11. And so that means the question mark would be 4 because it would be 8 to the 7th times 8 to the 4th. That would be 8 to the 7 plus 4. That would equal 8 to the 11th. So go ahead and stop the video. The answer key is posted in this folder. So just work through the rest of this paper and then check the answer key.